Good morning, everyone. Happy Friday. Welcome to TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's presentation will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Ms. Della or Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. I hope everyone is doing great. So we're going to get started with 1314 here. I believe Mr. Isasi might be logging in a couple of minutes. So for 1324, you might wait for a few seconds or a minute or so. Okay, so for today's, can you guys hear me okay? Okay. So for today's Happy Math Hour for 1314, we're going to be discussing linear and nonlinear systems of equations. And so these are all from chapter 7. And so let's go ahead and start. So basically, a linear system is made up of two or more linear equations. So you could have two equations, or you could have three equations. And our goal is going to be to look for a solution, which is an ordered pair. And your ordered pair is, again, you'll have a first coordinate and a second coordinate. Usually we call them x and y. And in order for it to be a solution, it has to satisfy both equations. Okay, so in a little bit, you'll see an example of what they look like when you graph them. So a system, we can either have a system that is linear, is a linear system that's made up of only linear equations, or we're also going to be looking at nonlinear systems. And whenever it's a nonlinear system, it means that at least one of the equations is something other than a line. So it could be a circle, it could be a parabola, it could be a cubic function. And then there's different ways of solving the system. So you have the substitution method, the elimination addition method, and then graphing. So from the three, the graphing is probably the least accurate one, because depending on your handwriting, sometimes you might mess up your points. Okay, so the best two methods to give you a more accurate solution would be the substitution or elimination addition. But if we were to graph these graphs, the solution is where the graphs intersect together. So for example, I have three pictures here. And the first picture, this is a linear system because it has two equations. And if we're looking for the solution, it's going to be the point where the two lines intersect. So in this example, our solution is going to be 2, 0, right here. If we look at the next system, this is a nonlinear system because it's made up of one linear equation and a parabola. So here, one of your solutions is going to be 2, 1, because that's where the lines intersect. And in this example, we actually have a second solution, which is 0 and -1. Okay. And then the third example is a nonlinear system, and we have a line, and then we have a parabola. And so in this example, where would our solution be? Any takers? So if you can see here, the two graphs do not intersect. So we would just write no solution as our answer, because there's no solution, or there's no point that's going to satisfy both equations. Okay, so next, we want to determine whether each ordered pair is a solution to the system. So basically, we want to know if we were to graph these two lines, would this be the point where the lines intersect? And so to do that, we want to check each equation. So we're going to take 2x minus y equals 4. and I'm going to substitute for x a 0 and for y a -4. So we end up with 2 times 0 minus -4 is equal to 4. If we simplify, we end up with 4 is equal to 4. And so I put a check mark here to indicate that this order pair satisfies this equation, but we also have to check the second equation. So if I let x equal 0 and y equals -4, then I get -4 is equal to -9. So here it fails to satisfy the equation. In other words, we don't get a true statement. So we say that the point 0, -4 is not a solution to the system. Let's check the second example. So here again, if I plug in -1/2 for x and y is -5, 2 times -1/2 is -1, and negative times a negative is a +5, so we get 4 is equal to 4. And then for the second equation, so it's important to check both. 8 times -1/2 is -4, and then we have -5, so -9 is equal to -9. So they both equations are satisfied, so therefore our point -1/2 and -5 is a solution to the system. So our goal is going to be for us to find these solutions. Okay, so we're going to go through the examples. And so here we have solve the system using substitution and elimination. So for my students, I go through the different methods, but on a test, I don't specify which method to use. And the reason for that is really you can use any of the two methods, whatever you feel more comfortable with. And so let's try the substitution method first. So for step 1, you choose one of the equations. So I'm going to choose x plus y equals 4. And then you solve for the variable. And you can solve for x or you can solve for y, whichever variable you prefer. So in this example, I went ahead and moved y to the right side by subtracting y on both sides. So we get x is equal to 4 minus y. So then what you want to do is you want to use the second equation that we haven't used. In this case, x minus y is equal to 2. And whatever we got in the first step, it tells me that x is equal to 4 minus y. So in my equation, wherever I see an x, I'm going to replace it with that 4 minus y that came from the first step. And as you can see, by doing this, I only have y's left. So if we simplify, then we get 4 minus y is going to be negative 2y, so right here. And then we're going to subtract -4 on both sides. So 2 minus -4 is -2. Divide by -2, so we get y is equal to 1. So again, our goal is to find the order pair, so we know what y is. Now we're going to look for x. So to find x, we're going to do something called back substitute. And at any time, if the screen is too small, you can make it bigger. Right above my blue arrow here, there's a magnifying glass. You can click on that, and it'll make the screen bigger for you in case it's too small for you. Okay. So to find the x, we're going to take our answer, which is y equals 1, and we're going to plug it into one of the two equations. In this case, I picked the first one. So I get x plus y is equal to 4. So x, and then I know that y is 1, so I replace the y with 1. So we get x is equal to 3. So the way we write our solution is in parentheses, so we have 3 and 1. So that was the first method. The second method is our elimination method. And here we get to choose any variable that we want to get rid of. So if you don't like your x's, you can get rid of those. If you don't like the y's, we can get rid of the y's. However, whichever variable you choose, you want to make sure that the coefficients are the same with opposite signs. So in this case, x has a 1, and this one, x has a 1. So they are the same, but not opposite signs. This has a positive 1, this has a negative 1. So I'm going to choose negative, I'm going to choose the y to eliminate the y. Excuse me. So once I can see that they're the same coefficient with opposite signs, I can add the equations. So I have x plus x is 2x, y plus negative y is 0, and 4 plus 2 is 6. Divide by 2, so we get x equals 3. And then to find the y, we back substitute, so you can choose any equation. And so for x, I know it's 3, so I replace the 3, plus y is equal to 4. Subtract 3, so we get 4 minus 3 is 1. So as you notice, the solution is the same. Okay. So those are the two methods. Now we're gonna just use whichever method we want to use here. But I'll give you some pointers of why I choose certain methods for certain problems. So if we look at this one, here we have 2x plus 3 is equal to y. So notice that I already know that y is 2x plus 3. So if my equation, let me see if I can use the pencil. Okay, so if my equation is set up like this, oops, and then let's say we have another one. So in other words, if my equation has the x and the y on one side for both equations, then more than likely I want to use the elimination method here. But if one of the equations is already solved for a variable, then for myself, I would prefer to use a substitution method because I already know what y is. So I'm going to take my second equation here, x plus 2y equals negative 4. And wherever I see a y, I'm going to replace it with 2x plus 3. So here I have x plus 2. Y, I already know is 2x plus 3, so I substitute that in here. And then we simplify. So let's distribute the 2. 2 times 2x is 4x. 2 times 3 is 6. Gather your like terms. X plus 4x is 5x. And subtract the 6. So we get negative 4 minus 6, negative 10. So x is equal to negative 2. So to find the y, we back substitute. So you can choose any of the two equations. So I'm going to go ahead and pick the first one. So I have 2x plus 3 is equal to y. So anywhere I see an x, I'm going to replace it with negative 2. So 2 times negative 2 plus 3 is equal to y. So negative 2 times 2 is negative 4 plus 3 is equal to y. So y is equal to negative 1. So my solution is negative 2 and negative 1. Okay, let's try another example. I think that might look like the same one. 2x plus 3. Okay, it's a little different. So I guess we can go here. Again, I know that y is equal to 2x minus 3. So I'm going to replace that in for y. So in the first equation, I have 3x minus 2 times y. So instead of y, we're going to replace it with 2x minus 3. Then we can simplify. So we get negative 4x plus 6 is equal to 7. Gather your like terms. 3x minus 4x is negative x is equal to 7 minus 6. So we get x is equal to negative 1. To find the y, we back substitute. So I'm going to use the second equation. So I get y equals 2x minus 3. So y is 2 times negative 1 minus 3. So we get that y is equal to negative 5. So here's my solution. And let's keep going here. Let me see. Okay, so let's try one that looks a little bit different. So notice here that my x and y are on the left side of this equation, and my x and y are on the left side of this equation. So for me, I find it easier to use the elimination addition method, because if I try to solve for x, I might end up with some fractions here, or if I try to solve for y, I might end up with some fractions. So the addition elimination would be easier for me to solve this. Okay, but that depends on each of us to make that decision, right? So you can pick either method. So now we have to determine which variable we want to get rid of. And so in order to get rid of the variables, the coefficients should have opposite signs of each other. And so we're going to eliminate the x's. So I need the 2 and the -5 to be the same. So in this case, I'm going to multiply the first equation by 5 and the second equation by 2. And then you'll see why we want to do that. Okay, so here's my first equation. I'm going to multiply it by 5. So 5 times 2x is 10x. 5 times -7 is -35y. And 5 times 3 is 15. And then the second equation, we're going to multiply by 2. So 2 times -5 is -10x. 2 times 3y is 6y. And 2 7 is 14. Okay, so now I have rewritten my equations, and now notice that one has a positive 10x and one has a negative 10x. So I can proceed with my method. So I'm going to add both equations. So I'm going to write them like this so that I can add them. So 10x minus 10x is 0. Negative 35y plus 6y is negative 29y. And 15 plus 14 is 29. So if I divide by negative 29 on both sides, then I get y is equal to -1. Now that you know the y, then we back substitute. And so I'm going to take any of the two equations, and I'm going to go ahead and substitute -1 for my y's. So here I get 2x minus 7. Y is -1 is equal to 3. So 2x plus 7 is equal to 3. Subtract the 7. So we get 4, -4. Divide by 2, so we get x equals -2. So this will be our solution. Okay, so the next example is similar. So which variable do you want to get rid of? Do you want to get rid of the x's, or do you want to get rid of the y's? So that is something that we can each decide to do. But the beauty of this is that no matter what you choose, and if your neighbor chooses something different, at the end you should end up with the same answer. Okay, so let's go ahead, and I'm going to use the elimination method, and I want to get rid of the x's. So here I have a -4, and then I have a +2. So if I can make this to a 4, then I would have the same number with opposite signs. So I'm going to multiply that first equation by 2. So I'm going to get 2 times 2x minus 5y is equal to 6. So 2 times 2x is 4x. 2 times -5y is -10y. 2 times 6 is 12. So I'm going to take my answer there. I'm going to have both equations. So 4x minus 10y equals 12 is what I got after I multiplied by 2. And the second equation is -4x plus 10y equals -1. So we can add the equations. So 4x minus 4x is 0. -10y plus 10y is 0. So we end up with 0. And 12 minus 1 is -11. And so 0 is not equal to -11. So that's a false statement. And so we say that this system is inconsistent. And basically that means that there's no solution. And more importantly, if you were to graph these lines, then you would see that the lines will never intersect. Okay, so now let's do a word problem. So the given amount of an annual interest is earned from a total of $9,000 invested in 2 funds that pay simple interest. Write and solve a system of equations to find the amount invested at each given rate. Okay, so when we're doing these problems, it's a good idea to try to break it down. So they tell us that we have 2 funds, but we don't know what these funds are called. So we can go ahead and call them A and B, or X and Y, whatever you want to use. And so all we know about the 2 funds is that if we add them together, they're going to give us $9,000. Okay, so we can come up with an equation for that. And so if I go on to the next part, I can write that as Fund 1 plus Fund 2 is going to give us $9,000. The other thing we know about these funds is that one of them pays 2%. So we can write that as a decimal. And so it's going to be 0.02 of the first fund, which we're calling A. And then the second fund is 0.06. So we're calling that B. But altogether, the interest rate that it accumulated is 380. So I can write that here. So now I have two equations. So now I can apply either the addition method or elimination method. Now, sometimes some of us, we might not like fractions or decimals. So if you want to get rid of these decimals, we can multiply the whole equation by 100. So that 100 times 0.02 is going to be 2a. 100 times 0.06 is going to be 6b. And 100 times 380 is 38,000. Or you could leave it as decimals. It's up to you. So now I have my two equations. A plus b is 9,000. 2a plus 6b is 38,000. So we can eliminate, let's eliminate the a's. Okay. So we eliminate the a's. I'm going to multiply that first equation with a -2. So -2 times a is -2a. -2 times b is -2b. And 9,000 times -2 is -18,000. So if I add these, they cancel out. And then -2b plus 6b is 4b is equal to 20,000. Divide by 4, so we get b is equal to 5,000. Now we need to find a, so we're going to back substitute. So here's my first equation, a plus b is equal to 9,000. I know that b is 5,000. So if I subtract on both sides, I get a is 4,000. Okay, so those were, so I like to write sentences for my answers if it's a word problem. So I can say we need to invest $4,000 into the first fund that is at 2%, and $5,000 into the second fund that is at 6% in order to gain, in order to accumulate $9,000. So here again, I just want to remind you what a nonlinear system is. So the two examples on the right, those are nonlinear systems because they contain, one of the equations is not a line, it's something else. The good thing is that they work the same way. So if you wanted to solve for, let me go back. This system, we have a line and then we have a parabola. So we can use the same ideas that we did for the previous problems. And so for this problem, I'm going to choose the elimination method and I'm going to get rid of these y's. Notice that I have a negative y and a positive y. So if I add the equations together, then I get, so here we get x squared. There's no other x squared, so I'm going to have x squared. And then I have a 4x. There's no other x, so I get 4x. Negative y plus y is 0. So we end up with x squared plus 4x is equal to 0. So now I can factor out. Notice it's quadratic, so you have choices, right? So I'm going to factor out an x. So I get x times x plus 4 is equal to 0. So if I set each factor equal to 0, then I end up with x equals 0 and x equals -4. And so now we have two answers for x. So we need to find the y's. Oops. So let me go back one. Okay, so if we let x equals 0 and I choose that second equation, 4x plus y equals 0, wherever I see x, I replace it with 0. So I get y is equal to 0. Okay, so let's go on. So I have to do the same for -4. So wherever I see an x, I replace it with -4. So we get -16 plus y. Subtract the 16 or add the 16, so we get 16. Make sure you write your solutions in as ordered pairs. So when x was 0, our y was 0. And when x is -4, then our y is 16. Okay, any questions on that? No questions? Okay. So I'm going to do one more and then Mr. Carizales will finish the other slides. So here we have a line, and then if you notice, this is parabola. So let me make sure it's not the same thing. Okay, it's not the same thing. Oops. So we need to decide what method we want to use. So again, you can use substitution or elimination. So I find elimination, if it's possible, will work better. So the first equation, I'm going to multiply by a -1. So -1 times x is negative x. -1 times negative y is positive y. And -1 times -5 is a positive 5. So if I put this information, I'm going to add both equations. So I get an x squared. Well, I get an x, and then I have the x squared. So those are not common terms. And then the y's are going to become 0, and then -11. So it's quadratic. So again, we can try to factor out, right? But in order to do that, in order to solve this quadratic equation, everything should be on the same side. So we'll add 11 to both sides. Now I can either factor or I can try to use the quadratic formula. And so in this example, we use the quadratic formula. And so if we plug in the information, b is -1, or b is 1, and then 1 squared is 1, 4 times a, which is 1, times c, which is 11. And if we simplify, notice we get -1 plus or minus the square root of -33. So if you have a -33, then that solution is an imaginary solution, which we cannot plot in our xy coordinate plane. And so here we say that there is, and it's in reality, it should say that there's no real solution. Okay, so there's no real solution, and we say that the system is inconsistent. Okay, any questions on that? Okay, so Mr. Carizales, did you want to take over for this example?
Excellent. Yes, thank you, Ms. Chuka. All right, so we have here for our example, solve the system of equation using any method. So again, we have our disposal, graphing, substitution, elimination. But for this problem, I think the the easiest way, I believe, I would like to do is to do the elimination method. Okay, so one of the things what we'll do is go ahead and again for the elimination method, let's get rid of in our case our x. So what we need to do is we're going to multiply a -3 to that to this first equation to the, and we know that this equation is a circle, right? The second one was a quadratic. Um, so when we multiply a -3 to our first equation, we're going to get this. -3 times x squared is -3x squared. -3 times the y squared is a -3y squared. And the -3 to the 25 is a -75. Okay, so this is our new first equation. We're going to add this to our second equation, to the 3x squared minus 16y equals 0. So when we add these two equations, we see that we've eliminated the x factor, right? So -3x plus 3x is 0, and -3y squared minus 16y is just -3y squared minus 16y, and minus 75 plus 0 is minus 75. So again, we can see that we have a quadratic equation. We can move all of our terms to one side for it to equal 0, so we can have it in standard form. Now, when we apply our quadratic equation, we're going to get okay, we're going to get this value, y equals 3. Okay, so all we need to do is we're going to use backward substitution to get now our x value. Since we had eliminated our x value, we got our y value, but now we need to get our y value. Now, it doesn't matter, again, as Ms. Chuka has presented, doesn't matter where we put this value to, either to the first or second. We'll get the same result either one, right? So on my case, I picked the first equation again. Let me plug in the 3 to the everywhere I see y. So I'm going to get x squared plus 3 squared is equal to 25. So 3 squared is 9. Subtract 9 on both sides. I'm going to get x squared is equal to 16. Take the square root of both sides, and I'm going to get x is equal to plus or minus 4. I'm going to two values, okay? So one of my values is 4, 3 and negative 4, 3. Okay. Now, if I were to let y equals negative 25 over 3, we can see that there's no real solution on this one too as well. Okay. All right, so our solution set is only these two values, so 4, 3 and negative 4, 2. Okay, so again, we were doing the two values because we had two answers from our quadratic equation. We had the negative 25, 3 and um, the value 3. Okay, so let's go ahead and look at this next equation. Solve the system equation. Again, we're going to use any method. Okay, so this one looks a little bit complicated. Okay, especially because we have this xy term. Okay, all right. So the method that we're going to use, and what I believe is the simpler method, is again to use now our substitution method. Okay, so for our substitution method, we need to solve for one of the variables and replace it to our other equation. So I'm going to choose the first equation, xy minus 1 is equal to 0, and let's solve for x. So when we do this, we're going to add 1 on both sides. Then we're going to divide by y on both sides, so x is equal to 1 over y. Now what I need to do is replace this variable to my second equation. Everywhere I see x, I'm going to replace it with 1 over y. All right, so we are going to get 3 times 1 over y minus 6 times y plus 17 equals 0. Okay, so let's go ahead and multiply the equation by y so we can get rid of that fraction. Okay, so when I do that, I'm going to get 3 minus 6y squared plus 17y equals to 0. Can rearrange it a little bit so it can look a little bit more in quadratic form, right? Hopefully, we recognize that now our parabola is on its side now because we are dealing with the y term. Our axis of symmetry is now the x-axis, no longer the y-axis, right? But we can solve this the same way nonetheless. We can use our quadratic equation to solve for our y term. And again, just to recap that it's the same, okay, my a value is -6, my b value is 17, and my c value is 3. So when I plug it into my quadratic equation, again, I have two answers again. I have a negative 1 over 6 and 3. I'm going to use backward substitution to get my x value. Okay? So we'll start with the negative 1 over 6, plugging it in. Again, I believe the easiest equation to use the backward substitution is that first equation, xy minus 1 equals 0. So when I do this, I have x equals negative 6. Okay, so uh, I'll do it again with my second answer, the y equals 3. Again, replace the y with 3, and I get x to 1/3. So my solution set for this problem is -6 and -1 over 6, and we have 1/3 and 3. Okay. Oh, I just noticed. I think I'm going too fast because was my last. Let me see. Well, let me ask. Does anybody have any questions? I think I went a little too fast. Let's see. Let's go back and oh, let's do this. Here, let's do this just so we can see that we're we're going to get the same solution. On my problem, what I did was I solved for x, right? Let's see if we get the same result if we had solved for y. Yes, let's go ahead and go back to where I get a white screen here. Let me get my pen. Okay, so let me get this first equation again. The xy minus 1 equals 0. Okay, so originally I had solved for y, but let's solve for um, sorry, we had solved for x. No, let's solve for y. So we're still gonna add 1 on both sides, so we're gonna get xy equals 1. Okay, um, and then I'm gonna solve for y. So let's divide both sides by x, and we have y equal to 1 over x. Yes. So when I plug this back into my equation, everywhere I see y, I'm gonna plug in 1 over x to get this, right? We have 3x minus 6 times 1 over x plus 17 equals 0. Okay, so what I would do, just as before, I want to get rid of this fraction, so I would multiply my equation by x. So when I do that, x times 3x is 3x squared. The x times the 1 over x just gives me minus 6. And 6 times 17 is 17x equals 0. Okay, so maybe for some of us, this is a lot nicer. Always look, we're using the quadratic with the variable x. Again, I can rearrange it so it could look like my standard form, which would be 3x squared plus 17x minus 6 is equal to 0. Okay, and again, I would apply my quadratic equation, and I would end up with the same answer. Okay, so again, let's just plug it in so we can always practice our quadratic formula. So x is equal to minus b, in my case is minus 17, plus or minus the square root, okay, of b squared, which is 17, minus 4. Okay, in my case, a is 3. Okay, in my case, a is 3. C is negative 6. All divided by 2a, which is 2 times 3. Okay, and when I get my answers will be now the opposite of what had gone before, but um, they're going to be these values. Um, x is going to be the negative 6, and x will be the 1/3. And I can do the backward substitution to get my y values. Yes. Um, so um, if there is no questions, I'll stay here. If anybody wants to ask questions or has a particular example or wants to go over more of substitution or elimination, um, Okay, well, if there's no questions, I guess we'll let you all out early this time. So we're almost done. I believe we have um, 4 more weeks or 3 more weeks for our semester to be over. So thank you all for joining us today. Wish you the best of luck. Keep on working on those math problems.